You ever wonder why some apps just feel instant while others lag and hang and just, crash at the worst possible moment? Well, the secret is often hidden in their design, in a really powerful approach called event-driven architecture. Today, we're going to pull back the curtain on EDA and show you exactly how it's changing the game for modern software.
We have all been there. You're trying to check out online, you finally hit that confirm button, and you get the spinning wheel of death. Or worse, the whole thing just freezes. It is so frustrating, right? So what is actually going on under the hood when this happens? Well, the culprit, more often than not, is a design that's as fragile as a line of dominoes. See, in a lot of traditional apps, every single piece is tightly connected to the next in this really rigid sequence. So if just one of those pieces fails, or even just gets slow, the entire system can grind to a halt. That's exactly why one little hiccup in a payment system can freeze up your entire checkout. So to really appreciate the solution, we first need to get a super clear picture of this old, fragile way that systems talk to each other. Let's call it the fragile domino chain. Okay, let's break this down. This slide shows the two approaches perfectly. On the left, you've got the old way, request-response. The best way to think about this is like a phone call. One system calls another, and then it has to literally wait on hold for an answer. We call this synchronous, and it creates that rigid, tightly coupled chain. If any link in that chain breaks, the whole thing just collapses. Now, look at the right. This is the event-driven way. It's so much more like a group chat. A component posts a message, an event, and then immediately just moves on. Other parts of the system can then read and react to that message whenever they're ready. This is asynchronous, and believe me, it is the absolute key to building apps that are resilient and can scale. So how do we actually break this fragile chain? Well, we need a totally new way for our systems to communicate. And this is where event-driven architecture, or EDA, makes its grand entrance. At the very heart of all this is the event, and an event is really simple. It's just a notification that something important happened. So in our shopping example, when you click buy, an order-placed event gets created. That's it. It's a fact, a record that something in the system has changed. So who creates this event? That would be the event producer. This is the part of the system that saw the change happen. So our ordering service is the producer. It creates that order-placed event and basically just shouts it out into the world. And here's the crucial part. The producer has no idea who's listening. It doesn't know, and it doesn't care. And on the receiving end, of course, we have the event consumers. These are all the different parts of the system that are interested in certain events. So when that order-placed event gets announced, you might have an inventory service that needs to update its stock count, a notification service to send you an email, and a shipping service to start packing your box. And each one of these consumers hears that same event and acts on it completely independently, all at the same time. Right, so you're probably wondering, if the producers don't know about the consumers, how does the message get from point A to point B? Well, that's the job of the event broker. This is the magic in the middle, the central hub. You can think of it as the system's post office. Producers drop off their events at the broker, and the broker makes sure they get delivered to all the right consumers. It is the backbone of the entire system, and it's what makes all this powerful decoupling possible. So we've got our key players, producers, consumers, and a broker. But how does this all really work together in the real world? Let's take a look at how this all builds up by looking at the two main ways event-driven systems communicate. The first model, on the left, is called publish-subscribe, or pub/sub. Think of this like a live announcement at a train station. The message is broadcast, whoever is there at that moment hears it, and then, poof, the message is gone. It's great for simple fire-and-forget kinds of notifications. But on the right, we have something way more powerful, event streaming. Here, events aren't just delivered, they're stored in a durable, replayable log. It's like a permanent record of everything that has ever happened in the system. Now, this is a total game changer. It means a new service can come online weeks later and read the entire history of events from the very beginning. This turns our post office into a central library for the whole business, and that opens up incredible possibilities for analytics, auditing, and even recovering from major failures. This ability to both decouple our services and to have this historical log of events, it lets us solve some really tricky problems, especially when it comes to keeping data consistent across a bunch of different independent services. One of the most powerful ways to do this is called the saga pattern. It's basically a recipe for managing a complex process that touches lots of different services. So let's walk through a successful order. First, the order service publishes an order-created event. The payment service hears that, it processes the payment, and then publishes its own payment processed event. Finally, the shipping service sees that the payment went through, and it starts prepping the shipment. It's like a beautiful, coordinated dance between totally independent dancers. But what happens when things go wrong? Let's say the payment fails. In a traditional system, this could be a complete disaster. You'd have an order stuck in limbo, and this is where the saga pattern really shines. When the payment service fails, it publishes a payment failed event. This triggers what we call a compensating transaction. In this case, the original order service hears about the failure and automatically cancels the order, effectively undoing the first step. It's like having a distributed undo button for your entire business process, making sure the system always stays clean and consistent. And look, this isn't just some abstract theory. EDA is the engine running behind tons of services you use every single day. When you place an order on a major e-commerce site, that's EDA coordinating everything. When your bank flags a weird transaction just seconds after you swipe your card, that's EDA. And when all your smart home gadgets are talking to each other seamlessly, you can bet that event-driven architecture is the conductor of that orchestra. So, with all this incredible power, is event-driven architecture the right choice for every single project out there? Well, not necessarily. It is a phenomenal tool for sure, but like any powerful tool, it comes with its own set of trade-offs. You should absolutely be thinking about EDA when you're building a complex system with lots of moving parts, like microservices, especially if you need it to be super scalable and resilient. It's built for agility and growth, but you might want to avoid it for a simple app or a quick prototype. The extra work of setting up and managing a broker might just be overkill. And if your process absolutely demands that everything succeeds or fails together all at once, well, a more traditional approach might actually be the smarter choice. So, as we wrap up, I want to leave you with this one question to think about. Your systems are already communicating, one way or another, but are they having the right conversation? Are you building a resilient, scalable network that can grow and adapt? Or are you setting up a fragile chain of dominoes, just waiting for one piece to fall? The choice, as we've seen, can make all the difference. Thanks for joining me.